Every year, millions of cars roll out of massive factories around the world. Conveyor belts move vehicle frames through long assembly lines while robots weld metal panels together. The automotive industry has spent more than a century refining these production systems. Yet one company entered the industry with the goal of redesigning the factory itself: Tesla. On the surface, Tesla is known for electric vehicles. The company's cars attract attention for their software features, battery technology, and sleek designs. But inside the company, another idea has been equally important. Tesla often describes the factory as the product. Instead of treating manufacturing as a background process, the company focuses heavily on how vehicles are built. Engineers analyze each stage of production, searching for ways to simplify components, reduce assembly steps, and increase automation. This approach reflects a long-standing principle in manufacturing. The more efficiently a product can be assembled, the easier it becomes to scale production. Fewer parts mean fewer supply chain dependencies. Simpler assembly reduces labor complexity and production time. But redesigning car manufacturing is not easy. Traditional automotive production relies on extremely large supply networks. Thousands of suppliers produce components such as engines, transmissions, electronics, and interior parts. Automakers coordinate these suppliers through complex logistics systems. Tesla chose a different approach in several areas. The company invested heavily in vertical integration. Instead of outsourcing as many components as possible, Tesla designs and manufactures many key technologies internally. Batteries, software systems, power electronics, and vehicle control systems are closely integrated with the company's engineering teams. This integration allows rapid iteration. When engineers modify a vehicle design, manufacturing processes can adapt quickly because many of the technologies are developed inside the same organization. But the scale of Tesla's production ambitions required an entirely new type of factory. The company began building extremely large manufacturing facilities known as gigafactories. These sites combine vehicle assembly, battery production, and component manufacturing within the same industrial complex. Gigafactories operate almost like manufacturing ecosystems. Raw materials enter one side of the facility. Batteries, vehicle structures, and electronic systems move through different production zones. Completed vehicles exit at the end of the assembly process. By concentrating multiple production steps in one location, logistics can become more efficient. Instead of shipping components across long supply chains, some parts move directly between manufacturing lines inside the same complex. This reduces transportation delays and simplifies coordination between production stages. But Tesla also experiments with new manufacturing techniques. One widely discussed example is large-scale casting technology used for vehicle structures. Instead of assembling multiple smaller metal components together, massive casting machines produce large structural pieces in single manufacturing steps. Reducing the number of parts simplifies assembly. Fewer components mean fewer welding points and fewer assembly operations on the production line. In theory, this approach can reduce manufacturing time while improving structural consistency. Yet building such systems introduces engineering challenges. Large casting machines require specialized materials, precise cooling systems, and careful quality control. Scaling new manufacturing techniques across high-volume production lines takes time and experimentation. Automation also plays a significant role inside Tesla factories. Industrial robots handle tasks such as welding, painting, and component placement. Computer systems coordinate movements across production cells. Sensors monitor equipment performance to detect potential issues before they interrupt production. However, the company's manufacturing journey has not always been smooth. Expanding production rapidly while introducing new technologies can create operational bottlenecks. Manufacturing systems must balance automation, human labor, and supply chain coordination. Even small disruptions can ripple through large production facilities. Observers sometimes note that scaling manufacturing is one of the hardest challenges for technology companies entering the automotive industry. Designing vehicles is only part of the challenge. Producing them consistently at high volume requires a completely different set of skills. Still, Tesla continues refining its factory strategy. New gigafactories appear across different regions, each designed to support local markets while expanding global production capacity. Lessons from earlier factories inform improvements in later ones. The result is an evolving manufacturing network. From the outside, customers see electric cars driving silently on city streets. But behind each vehicle sits an enormous industrial system. Robotic assembly lines shaping metal frames, battery cells produced at massive scale, supply chains delivering materials into sprawling factory complexes, and engineers constantly redesigning the production process itself. In traditional automotive companies, factories often follow long-established designs. Tesla approached the challenge differently. Instead of only building cars, the company is experimenting with how cars are built. And that manufacturing experiment may be one of the most important systems behind Tesla's growth.